Today we're looking at notes 5, 9, complex numbers. I really enjoyed this lesson. I hope you do too. So remember from before, a complex number is a number in the form a plus bi, where a is the real number and bi is the imaginary number. Okay, so if I ask you to graph a complex number, something like 5 plus 3i, it's actually quite easy because we consider the x-axis the real axis and the y-axis the imaginary axis. So you almost think of this real part as the x value and the imaginary part as the y value. So this coordinate would be like the coordinate 5, 3. So you'd go right 1, 2, 3, 4, 5, up 1, 2, 3. And that's point A. Okay, point B, this is the real part, this is the imaginary part, so this would be like the coordinate 2, negative 6. So 2 down 1, 2, 3, 4, 5, 6, that would be point B. Okay, next, this one here, negative 1, 4, so again, that's the real part, that's the imaginary part. So it would be like the point negative 1, 1, 2, 3, 4. So that's point C. Last but not least, point D does not have the real part, it just has the imaginary part. So the real part would be 0, negative 5. So I wouldn't go left or right any, and I'd just end up going down 1, 2, 3, 4, 5. And that would be point D. Okay, so easy enough, I think. How do you add and subtract complex numbers? Well, again, that's also pretty easy. It's just like collecting like terms. So given something like 3 minus 4i plus 5 plus 9i, you're going to combine what's alike, especially since there's a plus in between there. So the 3 and the 5 are alike, so that would be 8. And then the negative 4i and the 9i are alike. When you combine those, that would be 5i. And that's your final answer. Okay, the only difference here when you subtract is you can't forget to distribute the negative. So this would become 7 plus 2i minus 8 plus 5i, and then you can combine like terms. Okay, so the 7 and negative 8 would be negative 1, and then the 2i and the 5i would become 7i. So you're finished on that. Okay. So now we've done adding and subtracting, graphing. Now we're going to do some multiplication. Write this down. All right, so part 4, multiply. So when you're multiplying, you multiply very similar to the way you do with x's, except there's one small thing that you need to know about multiplication. When you multiply, remember that I squared equals negative 1. Okay, so I squared equals negative 1 because, I want you to think about, I is equal to square root of negative 1. Okay, but if I want to know what I squared is, okay, then I square each side. And so I squared would be I squared, okay, and what happens to the square root and the square here? Well, they cancel, and that leaves me with negative 1. So that kind of proves that I squared equals negative 1. Okay, this is useful because look at what happens when you multiply two i's, two imaginary numbers. So negative 8i times negative 3i would be a positive 24i squared, similar to if this was negative 8x times negative 3x. It's very, very similar. It works out the same. So here it's very useful to know that I squared equals negative 1 because plug in negative 1 for I squared, and what happens? Well, you multiply those two numbers and this becomes negative 24. And that's your answer for this one. Okay, so moving right along, next example, number 2. So similar on this one, except on this one you've got to distribute the 2i. So this would become negative 12i plus 6i squared. So go ahead and substitute in that you know I squared is negative 1. So when you multiply 6 times negative 1, that would be negative 6. So the only thing wrong with this is that it's not in the correct order. Remember, the real number has to go first, and then the imaginary part second. So just flip-flop their order. Nothing's jumping over an equal sign, so the signs stay the same. All right, how cool is this? Last but not least, multiplying two binomials together, you're going to use the FOIL method. So 3 times 4 is 12. 3 times 6i is 18i. Inner negative 2i times 4 is negative 8i. And then last, negative 2i times 6i would be negative 12i squared. So then here on this, you can combine these two middle terms. They're like terms. So 12 plus 10i. And the last thing I'd like to do here on this step is substitute in negative 1 for i squared. So then you can multiply these two together, so you get 12 plus 10i. Let me scoot it on up. And then negative 12 times negative 1 would be positive 12. And then, of course, last you can combine your two integers right here, 12 and 12. So that would be 24 plus 10i to make sure you put it in the correct order. Now, wasn't that fun?